In this video we're looking at logic. Now with logic, the first time you see it, it can be a little bit confusing, a little bit complicated, but as soon as you get your head around it, it's quite straightforward and you've got guaranteed marks on the exam. So for the purpose of your GCSE, what you've got to look at is what we call logic gates. Now these, for purposes of the exam, for a definition, take binary information and give an output based on the Boolean operations. Boolean means there are only two options, either a 1 or a 0, as we already know from binary. For each Boolean operator, there is its own logic gate. There are 3 of these different gates that you need to know. So we know that we can already store binary data in a computer, but these logic gates are what allow us to add, subtract, multiply and divide different numbers. So I've heard and I've read a couple of times people use an analogy like a doorman. So if you imagine a logic gate is like a doorman and they only let people in based on certain tests or inputs. So for example, if certain things are true, like they're over 18 years old, then the output is true, therefore they get into the nightclub. So I might use those analogies as we go through each gate to make it a little bit easier for you to comprehend and to kind of associate with. So logic gates are special circuits that are built into computer chips. They can only receive binary data and apply a Boolean operation. For example, you've got an AND, OR and NOT, which are going to be the 3 that you have to look at for GCSE. Then they will output a result based on certain conditions. You use these things called logic diagrams, which are often drawn to show logic gates and whole circuits. Each of the different gates that you need to do has got its own little symbol. These are the different symbols that you need to know. So I've drawn a box around the A-level only ones because once you progress into A-level computer science, you need to learn an extra 3 gates. But for the time being, you only need to know the 3 that you see at the top. So the AND gate, the OR gate and the NOT gate. You'll notice that there's lines going into and out of the gates. The AND gate is taking 2 different inputs and outputting one value. The OR gate is taking 2 different inputs and outputting 1 value. However, the NOT gate is just 1 input and 1 output. You really need to familiarise yourself with these different gates because you'll need to recognise them in the exam. Potentially you might even need to draw them. Okay, so this is the part where it should really start coming together and start making a little bit of sense to you. In the exam you might be asked to draw what we call a truth table, which basically shows all the different potential inputs into a logic gate and what the outcome will be when it goes through the gate. So each truth table shows all possible input combinations of 1s and 0 and then what the corresponding output is. Okay, so this is the first gate we're going to look at. It's called the NOT gate, otherwise known as negation. So a NOT gate basically takes a single input and gives a single output. The output is always the opposite value to the input. So if the input is 1, the output is 0. If the input is 0, the output is 1. You can see from looking at the diagram in the bottom corner that there's only 1 input and 1 output, and we've drawn our truth table in the other corner with the 2 different options for input 0 and 1, and the output shows that the input is reversed each time. So if you think about our analogy of a doorman or a bouncer, it'd be like walking up to him and being really nice and polite, and he doesn't let you in. So he basically does exactly the opposite of what you'd expect. You walk up and you're really rude and horrible to him, and he lets you in. So literally the opposite of what you'd expect is what the doorman does. Okay, next up is the AND gate, otherwise known as conjunction. The AND gate basically takes two inputs and gives one output. If both of the inputs are 1, then the output is 1, otherwise the output is 0. So the easiest way of doing an AND gate as a truth table is you draw your two input columns first and you count down in binary. So we start from 0, as we always do in computer science. Start from 0, then we go to 1, 0, 1, 2 is 1, 0, and 3 is 1, 1. So that is counting down from binary 0, 1, 2, 3. Okay, then for the output column, you just apply the binary logic. So 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0. But the last one, both of them are true. So 1 and 1 equals 1. Okay, going back to our doorman analogy. So if you imagine walking up to a nightclub and you see the bouncer, and the nightclub is quite upper class, so you need some shoes on. Okay, so both of you and your friend need to have shoes on in order for you to get in. Okay, so if neither of you got shoes on, you don't get in, so 0. If one of you's got shoes on, then you don't get in because your friend can't get in with you. And the same way, if your friend has got shoes on but you haven't, then you can't get in. However, if you both walk up with a pair of shoes on, then you can both get in, so the output is true. Finally, we'll look at the OR gate, otherwise known as disjunction. So OR gates take two different inputs and give one output. If one or more inputs are 1, then the output is 1. Otherwise, the output is 0. Okay, so the little diagram in the bottom corner shows input A and input B. Again, we can draw the truth table by counting in binary. So 0 and 0 is 0, 0 and 1 is 1, 1 and 0 is 2, and 1 and 1 is 3. So 0, 1, 2, 3, counting down in binary as the inputs. The output, we just apply the logic. So 0 and 0 is 0, because neither one of them are true. 0 and 1 is 1, because one of them is true. 1 and 0 is 1, because one of them is true. And 1 and 1 is 1, because both of them are true. Okay, so back to our doorman bouncer analogy. You're a little bit fed up now because you haven't got into the other nightclub, so you're going to go to another club down the road where you need to be a member. However, only one of you needs to be a member, and that member can take the guest in with them. So if neither of you are a member, the output is 0, which means you can't get in. However, if either one of you or both of you are a member, then the output is true and you can get in. Okay, that's all the different gates covered. So if you just make sure, go back over it again and look at the NOT gate, the OR gate and the AND gate. They're the three that you need to know. So familiarise yourself with the diagrams, familiarise yourself with the truth tables. Just check over it again, make sure you understand it fully. This little table at the end just basically shows the notation that can be used. So we can write out Boolean algebraic formulas, and it basically explains what gates are being used within the circuit. Okay, so if you ever see any of these problems written out with this notation, they're the gates that they're referring to. Thanks for watching this video. I hope you found it helpful. Please like and subscribe. Bye.